So welcome to our next practice session in our course Architectures of Artificial Intelligence Systems. And today we are going to talk about how to design and run machine learning pipelines using Kedro environment. As I already mentioned, Kedro is very popular, very good framework for pipelining. I strongly recommend this to start with that before you go into something more difficult like TensorFlow extended by Google. And in this series of videos, I'm gonna show you how to install Kedro, how to create a new project, how to register your datasets, how to start with simple pipelines, make them a bit more advanced, and finally how to run and visualize the pipeline. So let's start. All the tutorials are here in this website, docs.kedro.org. And as you can see in the first steps, when you set up the Kedro recommends to create a new virtual environment for running the Kedro. This is specifically because, as you can see, it supports the specific Python versions. At the moment of this recording is 3.10. Obviously it's gonna change in time, but in case you have some other Python versions in your environments, for example 3.12, it may happen that it won't work. So that's why it's good to run Kedro in a separate environment, which we are going to do now. So now let me go to my Visual Studio Code. Here we are. Let me start with the... So here we are. As you can see, I have my So here we are, and as you can see, I am in my base environment at the moment. So let me create a new Python, a virtual environment for Kedro. As you can see, I created with the name Kedro with the Python 3.10 as it's already supported. Okay, so now the next step is to activate that environment. And we are done with the installations. So now we have a clean Conda Kedro environment. Conda environment we named to Kedro with the proper version of Python. So the next step is to install the Kedro package. So let's do it with a simple pip install Kedro command. So now it looks like a Kedro is created. So following the Kedro tutorial, the next step is to create a new Kedro project. Let's do it with the Kedro new command. We are going to adopt the Dataiku projects on predicting high revenue customers here. So that's why I named this project as a new Kedro project high revenue. So I'm not gonna follow directly the tutorials from Kedro. We're going to use our baseline use case of high revenue customers here. So let's name it that way. I do not need any specific tools here. Okay, so it's here. So as you can see, I have a new folder here, which I'm gonna open now just to work in this folder in our next steps. So I ask Visual Studio Code to open this environment. I need to this folder. I need to activate my Kedro environment here. So we are in a given folder and we are ready to work. So the first housekeeping we are going to do is to edit this requirements file where we are going to install the project specific requirements. Maybe you have some your requirements like you would like to use for example some AutoML library. You can input it here. For us the very important part of this requirements are those files, Kedro datasets libraries, which enable us to read comma separated value files, Excel datasets, or Parquet datasets. If you'd like to use a wider range of different datasets, we would need to add them here. So let me save this file and now run the command pip install -r. So that means from the requirements and call this file. Okay, so we have installed all the requirements. And now let's have a look at the structure of our high revenue project, new project we did in Kedro. Firstly, we have here the configuration file, and it has two folders, base and local. In this base folder, extremely important file for us will be catalog YML, where we are going to register our data sets. We are going to do this in a minute from now, but there is also a very interesting local folder in the configuration file, which as you can see git keep here, and credentials. So for example, if you would like to keep some secrets within your projects which you wouldn't like to share with your peers using, for example, GitHub, you can put all those secrets here, and during the git push command it won't be sent to the repo. So you can do it. We are not going to do this, but still keep in mind that there is an option like that. It's quite well described in the tutorials. So this is the first file. The heart of our project is here in the source folder, where you have different pipelines. We're going to store pipelines here. Next tutorial, next part of this video, we'll register the pipeline to restore different settings. So now let's do some configuration. So we'll start with the registering the data set. So in order to do this, I need to copy the data set from the high level folder. So I will copy, I have it prepared there. So I will copy this data set, cp-r, that's its directory. Okay, as you can see, I have uploaded my data to this folder. Here I follow the data convention from data engineering convention from Kedro. So if you'd like to check it out, you can consult, for example, Kedro docs, data engineering convention here, just to see. As you can see, this is what is the data engineering convention. So once again, I really recommend you to spend a few minutes on reading this short description of different data types. You can see we have raw data, intermediate data, primary data, features, model input models, model output reporting, and these are described here in a very, very short format. This is very good convention, industry standard for working with data. We have our raw data set in this folder, as you can see. And when you look at this data, these are the comma separated value files with customer data, orders made by those customers, but I also uploaded the XLX file just to check whether Kedro can work with this data. So we put this data here. There's also no problem with reading this data from the BigQuery tables. You can also experiment with this. And now let's register this data in our project. In order to do this, we need to go to the configuration file, base, and catalog YML. And here I will register first datasets now. So let me copy paste this snippet here. And what do we have here? Firstly, we need to mention that these are not only datasets here, they are generally artifacts. So that may be a dataset as a source one, but that may be also the artifact of the as an intermediate step of the machine learning pipelines. You know that pipeline is a sequence of artifacts and components. So one component may result with some other artifact which may be either kept in the memory or stored somewhere. So if you want to store it, you should put it here. But that may be also a model. So the model may be also be here registered, and if you register the model here, it will be stored in this file. So what do we have here? We have the name, internal name of the artifact we are going to use in our pipeline, a type of this artifact, and the file path. Okay, as you can see, I have data 01 underscore row, which is this folder here. Yeah, so this is here. And I have also customers with the appropriate file. So now let me save this file and check whether it's visible to the Kedro pipeline. In order to check it, I call Kedro IPython session. This is the Kedro version of IPython because it reads some methods used by the Kedro. So let's read it. Let's initiate the IPython session, and in this Python session we will start with a simple command. We'll create the new object orders equal to catalog.load orders. As you can see, orders here is the internal name of the object. So let's load it, and now let's check orders dot head. Okay, and we have a dataset registered. So as we can see, we can access this dataset, which is here in the customer CSV, from within the Kedro. But we can also try to access the XLS file, XLS type file. So let's try this one. I wonder if it's gonna work. So I add a new artifact here, customers underscore XLX. As you can see, it is a different type of the data. Path loads are, I need this probably installed, so I will have to pip install. Probably if it's not installed, let me check. Open XL. This is library to read the Excel. Oh, but maybe it's already installed. That was a typo. That was a typo here. So yeah, it was already satisfied. So now once again, let's save this catalog YML file And now let's once again initiate the Kedro Python session. And now let's test it. So I call two functions in a sequence. Yeah, bingo, it works. So as you can see, we are able now to read customer XLS file. So different type of files. And we close the session with exit. Very good. The next step is to set up and run pipelines. So for that we are going to, in the first step, we need to create a data processing pipeline. So we are going to use a Kedro command to initiate such a pipeline. This is a command, as you can see. You can read it in the tutorial, but I call Kedro pipeline create data processing pipeline. Yes, we are going to have multiple pipelines for data processing, for modeling, for evaluation. But as I said, pipeline is a sequence of steps. So let me create the first pipeline. Let's see what's going to happen. Okay, so look what happened. We have here in our source folder now, here in the pipelines, a new pipeline. Can you see? This is a new object, a new folder. We didn't have this folder previously, and it have two different Python files. First are nodes. Next, we have a pipeline. In nodes, we are going to store our functions, which will serve as components. In the pipeline, we are going to combine those functions into a pipe. Yes? So a pipeline means that we are going to work with different artifacts and push these artifacts among nodes, between nodes. So let's continue. Let's go to the nodes part. And now we are going to create two functions here. Let's have a look. I have prepared it for you. So, as you can see, we need to open those libraries. We need to be assured that they are installed. If not, we are just simply install them. Next, we have the first function, prepare orders, which takes as input orders data and then makes different feature engineering stuff and returns orders by customer artifact. And then the second, prepare the customers, which joins orders and customers. Yes. So, and finally label customers, three different components here. Next, in the next step, we are going to assemble these nodes into the pipeline. So at the very top, we are going to import, I'll substitute this with the new line. Yeah, I'm gonna import throw.nodes file, those three functions, which are our components. And now I will define the pipeline. Let's have a look what happens here. I have a function which creates the pipeline object, returns the pipeline as a sequence of nodes, and in each node definition I have prepare orders. This is the function which is a component here. The information about the input and output, and the name of the node as visible within the Kedro. So this is the function, this is the name of the node, this is the input, this is the output. For us, the most important thing is that the first input in a pipeline should already be registered. So as you can see, I have in catalog, I have this orders, so it's registered, yes, so it should be visible. And then next, prepare customers. Look what it happens. It takes the customer as input. So once again, we have customers defined here, so it's correct. Next, it takes orders by customer as inputs, and we need to be assured that we have this object. Yes, we have it here because this is the output. Output, yep, this is here. This is the output of the previous node, so we are done. And this node outputs the customers prepared. And the name of this node within the Kedro is prepare customers node with underscores. And finally, we have another element in the pipeline. This is the function label customers. Once again, this function is available here, as you can see in our nodes library. Yeah, it's here. And it takes as input customers prepared, which is the output of the former latter node, yeah, this one, and outputs customers labeled. Yeah, so, and the name of this node within the pipeline object is label customers node. So now let's give it a try. It may happen that we didn't install the appropriate libraries like agents, so I will just simply take care about this. So for sure I need to pip install in my nodes in my project user agent, so let me do it. This is the example of this project specific libraries I should take care about, but I forgot about this. Okay, and now let's try if it works. I tested with the following command: Kedro run minus nodes prepare orders node. So now I can test whether the single node works. So it's not the whole pipeline, but I call a first node from this pipeline. As you can see, this is prepare orders node. So this is the first one. Let's test it. Yeah, it looks like it worked, but look what happens here. It saved orders by customer, not to the drive, it's not stored, but as a memory dataset. So it worked correctly, but we do not have this artifact written. Yes, so it works. And now we can test the whole pipeline, and just with the simple command Kedro run. Let's have a look whether it works or maybe it will blow up. Let me check. Yes, it works. So as you can see, I have all the pipeline run correctly. So this step by step, look running the node, prepares node, and it resulted with the orders by customer and saved this orders by customer to the memory dataset. Completed first out of 3 tasks. Next, loading data from customer CSV dataset and from the memory dataset orders by customer and running now prepared customers node. Let's have a look. It's here, yeah. It's a bit higher here. This is the second. Okay, prepare customers. And it saved the output customers prepared once again to the memory dataset. Yep, so this was the second task, and in similar we have the third task completed. So it's very nice. So we did it. So before we continue, we will try to persist a dataset. those data sets. Yes. So for example, imagine that we would like now to store those files, which are at the moment memory data sets, somewhere on drive, which is not always sensible, but because at the moment we work with the very light files, but imagine that these files are large and you have plenty of different runs. Keeping those files always on drive may have no sense, but for some of them, sometimes you want to track. Yes, so let's do it. So now I will just simply correct our catalog YML with this one. As you can see, look what happens here. I have much more data sets. I have original data sets, orders. I need to correct this letters because it's taken from the former version of the Kedro, so that would generate the error for sure. So let me correct this. Yeah, but now it should work. So what happens here? I add a new folder here. Can you see? 0 to intermediate. In our data folder, it's not there. Can you see it's not there? So now I ask Kedro to store intermediate results of the pipeline, intermediate artifacts into those folders. Moreover, look what happens. I ask them to store this in the Parquet dataset. For you who is not familiar with Parquet, I strongly recommend you to read about this Parquet versus CSV. There are many different comparisons of that, but as you can see, yep, let's have a look. And this article, for example, in LinkedIn, there are many comparisons like this one. It's not the good, that's not the best choice. Let me check. Let's see this one. Pros and cons of different. Yep, that's very interesting. Can you see? Data stored in the CSV file on Amazon, 1 terabyte in comma separated value corresponds to much less amount, 130 gigabytes in Apache Parquet format, and the query time is killing faster. Yep. So, and the cost is much cheaper. So that's for tabular data. And if I can recommend you something, if you have more than 1000 rows, there's no sense to store this data in CSV file or transfer them via email, whatever. It's error prone. So it's much better to use Parquet, and that's what we are going to do now. Look, I store those intermediate data sets as Parquet data sets, and later then there is no problem to read such a data sets using pandas. Yes, instead of pandas read CSV, you ask pandas read Parquet. Yes, so that's all. But yeah, and there is also custom level. So let's try this now. Yep, correctly. Look what happened here. We have a new folders. As you can see, I have Parquet data file with customers prepared and primary data set with customers labeled, which will be the input for our next modeling stage, modeling pipeline. So that's for basic pipelining with Kedro. The final thing in this part of this tutorial is to show you how you can visualize such a pipeline. So let me install for that a Kedro Viz package. If it's not already installed, let me check. Once again, I am within our Kedro environment, Kedro Conda environment. So let's install it. Oh, it was already satisfied. It was one of the requirements I did. It was in the requirements.txt file I did previously. So now we can run this command Kedro Viz with the option of automatic reload, and let's have a look what's gonna happen. So we have a new version that was the information, but look what happens now. I have a beautiful visualization of our pipeline. I can drill down to the details. I can check the data set. I can see the file path, data statistics, number of columns, number of rows, number of files. Next, I have a function. Yeah. So this is our component, prepare orders node, some basic information about the function, file path, information how to run this function, just precisely this row, this command, which is not only handy during the development stage, but maybe later on used in production. Yes, if you would like to call just a single node, we can do it from the script with that command. Moreover, if we want, we can show the code. Look, I can show the code. Yep. So I have all the code for just for inspection if you would like to monitor in case there is something wrong. Moreover, as you can see, I have a flow, a very, very simple flow described here, plotted here. So this is something similar to the professional visualizations from tools like data science platforms. Moreover, later on, we're going to see how to, you can use it. I don't know whether I'm going to show it to you, but you can also track your experiments in a very simple way using the experiment tracking tool. Okay, so that's all for this part. The next step will be adding a modeling pipeline. So let's do it. I will add a new session here. So as previously, I'm gonna add a new pipeline to our own pipeline. I need to initiate a new Kedro. I need to initiate our Kedro environment. And the next step will be to add a modeling pipeline. So I will do this with, as previously, for data processing pipeline. As you can see, I create Kedro pipeline, create, and modeling pipeline. So what happened here? Look, in our source folder, let me show you, in the project folder in pipelines, I have a new object, data modeling, prepared. Let me close the previous pipelines, and as previously, we have nodes, Python script, and the pipeline. Oh, it's not here, it is here. Nodes and pipeline. These are empty now, but as previously, we are going to store components, and here we will combine those components into the pipeline itself. So let's do it. I copy paste, I have this file prepared already. So for nodes, I'm gonna copy paste this, and these are some errors here, but let's go. What we have here? We have pandas imports. We have scikit-learn model, a scikit library used for train test splitting. We choose a single decision tree classifier and logistic regression models. Next, we are going to import some metrics like accuracy score, receiver operating, area under the curve score. Yes. We also use some preprocessing with min-max scalars. So let's go slowly through our functions. First one is preparation of data for the modeling. Yes, so as you can see, we have some simple feature engineering, we split the data set into features and the label. Our goal is to predict whether the new customer is gonna be high revenue or low revenue. Yes, so we store it as a Y. Next, we select numeric features, categorical features. Yes, perform some scaling of those features. Yes, and now this is should be commented. We create a data frame with the features and labels. Yes, and this is the first node, first component. Next, we have the new function which splits the data. Yeah, so it returns features and labels split it into train and test data sets. Yes, in the proportion 80-20. Next, we train the model, taking these data sets as inputs. So once again, some typo here. It was during the import. We use as model a decision tree. Yeah, logistic regression at the moment, but we cannot command this to use either a random forest or a decision tree. I choose logistic regression just for sake of simplicity. And then I fit the model and I return the trained fitted model from that. And finally, I have an evaluate model function which takes the test data set with features and labels and the model, performs some computations, computes accuracy, receiver operating curve, prints out the results and logs them. Yeah, so this is the print out we should have as the outcome. So that works like that. Now let's try if that works. So before I do this, I need to assemble this pipeline into the modeling pipeline. So let's me copy paste. I have it prepared for you. Modeling pipeline in the following format. So what happens here? Obviously, I import basic objects. I import my components from nodes. So as you can see, I have three functions here. And I import here prepare data for modeling, split data, train model, and evaluate model. 4 components here, yes? And I compose those components into pipeline the same way we did for data prep pipeline. So, prepare data for modeling. Yes, this is the first node. It takes as input the output of our former pipeline, customers label. I wonder if you remember data processing pipeline returned this object. And it takes it as input. Yes, you can check it in our nodes file. It takes some data frame as input and returns data prepared. So it's visible here. It returns data prepared for modeling output. And the name of this node, this component within the pipeline is prepare data node. The same for split data, the same for training data. As you can see, the train model function takes as input features and labels from the training dataset and outputs the object name classifier, which is the trained model. Yes, I name it classifier, but as you can see, the output of this function here is a model. So I name this model classifier in my pipeline. Later on, I can obviously store it as a file. If I do not register that in my catalog YML, it will be kept in the memory. Yes, but it may be later on be used. And finally, evaluate model. I read the function of evaluate model. It takes as input the classifier, the trained model. Yes, which results is here, and the test data set with features and labels, and that node, that component is named evaluate model node. Okay, so have it. And now let's make a crash test the pipeline. Let's have a look what's gonna happen. Yep, very good. So as you can see, we went through the whole pipeline, both data prep stage and modeling pipeline. Yeah. So we went through this pipeline and we have the model trained. We have the model evaluated with the printouts on the screen. Once again, we can visualize this pipeline with Kedro. So let's have a look. Wow, it's being updated automatically. That's because we called this function with minus outer load function. Moreover, maybe you have noticed that I didn't kill the terminal where this process was running. So thanks to that, I have this pipeline here visible and being updated automatically. So as you can see, this customers prepared node object is then pushed to the label customers node. Yep. And data prepared for modeling. Then we have the splitting data. As you can see, it's split into the test and train data sets. And then the train data part of the data set after the random split 80/20 is pushed to the train model node. Once again, we can click this node here and we can click it and show the code as previously. We can see the code just for the inspection. Yes, just to see, for example, that we are going to use logistic regression model for that. Yeah. And then this is finally results with some evaluate model function which prints out the results. So that completes the very basic version of the modeling. You may ask yourself, okay, so why to complicate things? Why should I use instead of just a sequence of functions within my project? Yeah. Look, at the moment, if you look at this pipeline, it's already a bit complicated. It's still quite easy, but it's becoming complicated. But imagine that in the real case scenario, we are going to have dozens, if not hundreds of components and artifacts. Then this picture is gonna be very, very messy. And after some time, you truly may lose the control over your code. You won't see what reads which artifact, how they are connected, and it's gonna be very messy. The next, from my practice, yes, benefit of using that way of writing the code, working with the modularized code, because this is a kind of the modularization, is that you can test a specific pipeline or even a specific node within the pipeline from the command line. Look, I can type Kedro run -- pipeline and run only modeling pipeline. Yes, so I do not need to run whole the code. Yes, or I can type here pipeline data underscore processing. Yes, it will run that part of the pipeline. So I can go even further to run truly only a single function from here. Look, if I have this module, yes, this is label customer node, and this is the file path. And look, Kedro run, how to run this node. So I copy paste here, and I have only this node run. So this is extremely important. Why? Because it runs the node to this node, so I can run the whole code until that node. Yeah. Or but if I type here, let me give it a try. Yes, it runs only this node. So I can very granularly approach to my code testing. So imagine that there is something wrong in a pipeline. I did it very carefully. It's not always like that. In many cases, during the development stage, you will have a lot of different problems with such a pipeline. Then you will see there is something wrong, but then you can work on a very specific node by yourself and then monitor without running the whole pipeline, which saves your time. Yes, and make debugging very, very easily. So there are plenty of different opportunities here, and that's why I recommend you to use pipelining tools for managing your machine learning pipelines in the future. So now let me present you some very useful, handy tool which will help you to modularize your pipeline. We'll start with some visual tweak. If you look carefully at the small change I added here in our catalog YML, I added an extra metadata in the artifact description. This metadata is Kedro vis, so it's for visualization, and the name of the layer. I added layers, row layer for our original dataset, and intermediate for some intermediate artifacts. Okay, orders by customer and customers prepared, and finally some primary and models layers. So how does it impact our visualizations? It will impact only visualizations. So now let's have a look at what have changed in our Kedro pipeline. So as you can see, this is the pipeline in the original form. Let me make it a bit closer for you. Okay, so it looks like that. And here I have a button which enables me to show different layers. So show layers, yes. So as you can see now, let me show it to you. I have the primary layer here, yes, and then I have let me scroll it for you. Yeah, we have a row layer, intermediate layer, and primary layer in the visualization level. So that sometimes helps you to work with data sets in different layers, yes, just to make it a bit more better to explain it to you or to your colleagues or to business users. So I can hide and show layers, yes. A bit more advanced is a next tweak where I'm gonna create nested modular pipelines. So for that purpose, I will modify data processing pipeline. At the moment, it looks like here, but now what I'm gonna change it to that way. As you can see, I have created a dedicated namespaces here, data prep namespace. So I put all those nodes into a single namespace. You need to be very careful with that because it requires some changes also in the catalog YML or in some other places. So in order to play with that, just read carefully all the tutorials. So let me run this pipeline for you just to check whether it works correctly. So let's once again push the Kedro run. So now it runs, and now let's have a look how it looks like on our visualization. So as you can see now, if you look closer, we have all the data prep hidden here under such an object. So if I click this object now, it will decompose the pipeline to showing different steps which are here. So where is that useful? That's useful when you have extremely complicated pipelines in order to cope and manage with such modules. So in case you have, in case the complexity of the pipeline grows, I definitely encourage you to use this. It may take you an hour or two to go through the tutorials to work it out for your case. I did it many times in my projects, but it definitely pays off. Okay, and that completes our tutorial on Kedro, pipelining with Kedro it's a very mature solution. It has much more options. At the moment, we were using this on our local machine, but I encourage you to run this Kedro pipeline on the hosted solution on your virtual server, for example, at your cloud provider. Next, it would be good if you could try different options of deployment of such a pipeline, or I have a set of scripts for that to read the dataset in streaming dataset from external sources, which is very, very difficult. Maybe not that very difficult, but it needs some fancy tricks. Moreover, in the deployment section of the Kedro, you will find a very advanced tutorial on how to create an object, YAML object for Kubeflow deployment on Kubernetes. So it's a kind of the integration where you can move your pipeline from a single machine to Kubernetes, where each component runs as a Docker container. Yes, you can do it with a dedicated integration to Kubeflow. So once again, I hope it will help you develop your future projects. I'm keeping my fingers crossed, and good luck.